So we've been on a journey that introduces us to AI, and we've started off with from decision trees all the way through to machine learning, and we've touched on various algorithms and various theories as well, and all the way to the last session where we started looking at the human side of AI. And we looked at what roles you could play. We had two sessions to go back and forth on it, so we didn't get a chance to review some aspects of what was already discussed. And that has taken us to start considering ethics in AI. And mostly when you're talking about ethics, you are thinking of ways that you will secure yourself or protect yourself as a developer, and also to protect those who will be using the tools that you are developing. You never know. There are some designs out there that have been around for many years, but they are now being pulled back for further investigations because they react differently in different scenarios. Some of the examples that we will actually look at them today, and some of them not necessarily on your slides, but we also talk about them. If it is research wise, mostly you will go through formal ethics approval before you conduct any formal research, because pretty much you want to make sure that the questions you're asking people, you're not going to create harm. And of course, people are giving their consent. And similar things, of course, apply to artificial intelligence as well. It's just recent that AI has been a big boom. It's been around for ages, but in terms of the practicality of it, recently it's just become huge. So meaning that there are still some challenges that are yet to be considered, or some also known. So if we look at some of the examples we have been looking at in our news in AI, even if we just break it down to some very fundamental ones, which we apply on daily basis. For example, if you're a social media user, or even if your phone has facial recognitions app, or these days, even if you take pictures, it can automatically try to find the faces on your picture on your phone without even plugging into social media, and then you can tag it. So if you're using face tagging, for example, you're already making use of AI. If you have a smartwatch, I'm aware that the Apple smartwatch now has heart rate variability feature, so can start raising alarms about your heart rate if, let's say, you need to see the doctor immediately, or even take the data with you to show your doctor for some suggestions. Tesla, well known for self-driving car features, and of course, not just Tesla, the other brands that can do things like auto parking. And even as we speak, like Toyota in some of its cars have some self-driving features. Once you enable the radar, it can automatically detect where the road center lines are and try to balance the car within these center lines. As soon as I drew it, it disappeared. So try to balance the car within these center lines. And things like if you are behind another car, it will automatically slow down within the right range. So at least adjust the speed, use it of information from the current speed limit, which it captured from the road sign. So let's say you have a road sign which says maybe current speed limit is 60, for example, and then the current speed you are going, and then the speed at which the car in front of you. So there are some of most of these things already available to us. And of course, if you know a driver, at least you one way or the other would have used Navigator to find your route around, and things like auto route, alternative route computations for current route that you're using on things like Google Maps. And we have also, by the way, talk about various examples in terms of applications of AI. As wonderful as these things are, they are designed by people, and of course, they are not without errors or not without some complacencies and some issues which can also creep into our life, because we did talk about embedding ourselves in AI or augmenting ourselves in AI. And as we start not moving from just even developing some new models or some AI application to using more existing ones or existing tools to improve our lives, it's important that we start considering what are the potential issues, what are the potential flaws that we can come across, and as developers that we might also introduce. I double check, can you hear me clearly up to this point at least? That's good. So we're going to start off from the technical side of AI or technical challenges.
This is a little faint. Your voice is a little faint, so please speak up.
Sorry?
Please speak up. Your voice is a little faint.
Oh, really? Were you able to follow what I said before? No.
Pardon?
Quick recap of what I've just said, just in case for those who didn't hear me. It's just pretty much we are surrounded by AI, and of course, it's important to know its implications and potential flaws, right? I do have coffee for me, so I'll drink from time to time to clear my voice. Hopefully this is better. And can I continue at this pace?
Hey.
Yes?
Yeah.
Good. So if you look at the main challenge of AI, pretty much the main challenge goes around classification errors, right? And what we are looking at with artificial intelligence is basically automated categorization. And if you're thinking about automation, especially where it involves machines, there are likely to be errors introduced, and you're thinking about human beings that develop these machines introducing potential biases, potential errors due to the way we are, because we human. They say to err is human as well. And if you look at the potential issue or potential damage that can be caused, you will say it's better to avoid these damages before releasing your model into the field, or before releasing your application or project into for general public use, because especially with the boom of social media, things spread a lot quicker than we think. You may go viral for the wrong reason. Okay, so if we look at the two main categories which we have looked at supervised and unsupervised learning. So with supervised learning, probably mentioned quite a lot of time. We're looking at new observations into existing criterion. Pretty much you provided your training data set, and it looks at or matches the new observation based on existing data that has been used to train. So some existing data have been used to train this model, and then when new ones come in, it can try to do some categorization for it. And with unsupervised, we are looking at the data and we're trying to identify some similarities in order to learn from it and also come up with models for us. And of course, you can think more about reinforcement learning and other things, but pretty much if you look at the two here, there is still ways that things could be right or things could go wrong. And sometimes it's not always obvious until you look at the output of the model that you have created. And the main point we're trying to make with all of these slides or this particular session is that don't just jump into, I've trained the model, accuracy looks good, and hence I'm launching it and it's good enough for it to be used for real human use or to be used in the field. So, I mean, rest was saying, of course, making use of these two, we can come up with all these wonderful applications that we have looked at in the past. So let's see how things can actually go wrong with the first example, which would be Miracle AI. And hopefully you can hear me. I'm just going to read through it quickly. Even if you can't see it, at least you can follow my voice, right? So working with the chatbot, right? Did you get anything for the holidays? Response: yes, a box of children, chickens, and chocolate. I see the logic of CH, but not sure where you can buy a box of children from. Some more examples. And these are real world applications coming from big companies, okay? So in 2015, Google's image recognition software, famously classified, sorry, I'm going to use the word black and white for the remainder of the session, because that's what we're familiar with, or the most widely used words, and it's just an example. It classified most Black people as gorillas, and you can look, and unfortunately, this is also something that goes with a strong stereotype as well. I like the response A in the classroom, so I'll just leave it with A. Then 2 years later, 2017 comes Apple with iPhone X, which couldn't recognize or tell apart different Chinese people. So it couldn't recognize Chinese faces. And that's coming from Apple. So we've got Google, Apple, and of course, this created a big roar in the public as well and offended quite a large number of people. And if you look at the number of people who use our demographics in terms of countries that buy a lot of Apple products, you will see the relation with the Chinese customers there as well. It's good to have a quick search to see its impact and or how far this particular mistake reached.
Please, we can't hear.
Can you hear me now? I'm not sure what I said.
Yes.
Bear with me. So 2 things: Google associating Black faces with gorillas, iPhone X, this 2015, and that's 2017. Not too far back. iPhone X not being able to tell the difference between Chinese people and of course being classed as racist. Then I would say another serious one, we have military drones that wrongfully killed people as well. And I did say in the first cohort that I had a video. You're more than welcome to look it up. A video which I wanted to share with you of sort of a commentary on the drone attack. And I think it was a bit too graphical. And I couldn't bear it myself. So I decided not to share it with the class, but more than welcome to look it up to see its potential implications. And there are, of course, other cases where we have drones meant to be targeting particular cars, but then causing damage beyond sort of what was meant to be the safe zones, or attacking, affecting civilians or killing civilians in the neighborhood as well. And as much as these are interesting in terms of how things can go wrong, it does affect people's life and can cause life or death scenarios, or sometimes things like racial issues. So let's look at some of the potential causes. Sorry, I'm going to try to keep speaking up. I don't know why my sound. So things like dealing with accuracy, right? So if you say accuracy can be misleading when it comes to categorizing data. So you just don't want to rely on the percentage that are correctly categorized when dealing with your models or evaluating your models. And a particular example that we look at was the confusion matrix when we looked into, remember, false positive, false negative, true positive, true negative side of things. And we used an example of COVID. We'll talk more about it as we go on. And this, of course, not just with COVID scenario that we looked at, it's mostly when you are dealing with rare cases, okay? So if you're dealing with things like rare diseases, that is where you are likely to end up with imbalance in the data set that you're using, for example, to train your model. So looking at classification errors in artificial intelligence. And of course, the big question is what is causing the error and what can you do about it, right? And one important thing to think about is basically something from mathematics. And I'll say straight away, I'm not a mathematician, you're more mathematicians than I am, right? Is to look at the Bayes and the Bayes theorem. And what that says is it basically tells you that the probability of an accurate conclusion for the given data is affected by several factors. And of course, some of these factors include the probability of true positive. So basically, when you put what should be, what is right as what it should be right in the right category. So we have the true positives there, right? Sorry, if I had something in the classroom. Was that a question for me? Are you happy? Can you hear me all right?
Yes, please.
Okay, that's good news for me, right? So another one is also the false positive. So basically when you put you don't actually recognize the right category. Basically it's the case, but it's just been identified as false. And of course the base rate of outcome, but I mean there are a couple of slides that follow this particular one, but I think what does better justice is when we look at the confusion matrix. So I'll just throw it in here right now. We're not going to use the same example because we've gone through it, but at least it allows us to touch on some things. So remember we had our true positive, and then we had our true negative. Yes, does this ring a bell?
Yes.
That makes me happy. And then we have the false positive. Sorry, changing the pen changes everything. And then we have the false negative as well. And we did say one of them is type 1 error and the other is type 2 error. Which one was type 1?
False positive.
And then which one was type 2?
That's type 1.
And which one did we say is quite dangerous?
Type 2.
Very well. Sorry, I missed you on the last one. Can you come again, please?
What?
I can't hear.
What did you say?
Which one did we say is quite dangerous?
Type 2.
And why did we say so?
I think this give an example which was related to the cancer diagnosis. Said for type 2, which is the fourth rate, better for the person to like know that he's negative and then later confirm that maybe he's positive. Better for the person to
is negative.
It's better for the person to think that they have cancer and find out later that they don't have cancer, than for them to think that they don't have cancer and later find out that they have cancer. So pretty much just simply looking at the accuracy alone is not enough. And we did look at example where we said if you were dealing with, I think it was 8 out of 90, 8 had the cancer and then 90 didn't have. So there wasn't a balance in the data set, of course, leaving out 2, which you can add. So there wasn't a balance in the data set and we were ending up with very high accuracy, but other metrics reviewed that, of course, the accuracy wasn't enough to draw to a conclusion. I think that does better justice in terms of explaining things than this couple of slides that follow, but I'll just highlight some few things in terms of the potential issues or real applications that you are likely to have such rare cases. Okay, so I try to write something which I couldn't finish writing, but I'm going to write it now to see whether you can do better pronunciation than I would, right? So that would be cystic fibrosis. I'm not going to pretend to be a medical expert in the room, but at least what I can highlight is that for cystic fibrosis, you've got 1 out of 3,000 newborns having it. And by nature, if you look at the reality in terms of the data that you are dealing with, real world data, it's quite imbalanced in nature. And then if you are looking at things like ALS also affects 30 out of, sorry, I think the pen's just trying to merge up here. So it affects only 30 out of 50,000 people. And you can get more examples as well. So yes, it can happen, and just simply jumping to accuracy does not alone review the reality in terms of how your data really will perform in the field, whether it's going to cause type 2 errors or not. So don't just simply look at accuracy, present it, and say, yes, you have 99% accuracy, and then everything is wonderful, everything is beautiful. You may be causing more harm than good, actually. So again, I'm just going to skip this because we have talked about it in a nice way. Can I pause here and give us about 5 minutes break, and we come back later, hopefully more refreshed.
Good. Yes.
Did you say you don't want the break? Continue record. Yeah, so what are some of the contributors to the errors that you have if you're looking at limited variability in data set that you are working with? Can I double check? Can you hear me? I think it's a lot. Okay. So if you're looking at limited variability in the data set where you do not cover all the possibilities, or basically you're just viewing your data and its evaluation for a very narrowed angle, then you are likely to have errors. I think the word is oximeter. Yes, that little device that they put at the tip of the finger to measure the amount of oxygen in a person's body. Recently, there was this big issue raised in the UK, actually, I think just after COVID lockdowns and other things, about the oximeter inaccurately measuring the oxygen intensity between people of different skin tones. So on average, for the darker skin tones, it wasn't measuring the right amount of oxygen. And there were speculations going around that it contributed to higher number of deaths for COVID patients who were from the minority ethnic groups. So that's also something interesting. That's just something on a design floor, not necessarily an AI thing. But of course, when you are gathering your data or looking at test scenarios, please, you want to start considering wider range in terms of the potential possibilities. Because, well, it may not be today that someone may flag it out, maybe years after you've designed it. And sometimes it can have strong legal complications as well. So want a bit of diversity in terms of your raters, or when you are doing your rankings in terms of data that you're looking at, you don't want just homogeneous data. And of course, how to deal with it will be the opposite. Okay, so you want to look at algorithms that are evaluated for, of course, overall accuracy, and you want to consider more than accuracy, just as we looked at, not just ignore bias in potential subgroups as well. So if you do ignore bias, and you're potentially going to have errors in your system. So if your algorithm does not also generalize well to new situations, or does not really adapt to new situations, you're likely to have errors. Later, we talk about stability error and other things. And of course, if there is lack of accountability, if you simply just design implement model is out there to be used. Nobody's accountable. Nobody's being held accountable. No proper ethical consideration is being given to your development. You are likely to have errors as well. So some basic things, but really crucial that you start considering them now. So offsets, overcoming these errors. We're doing well for time. Hopefully we finish well in advance. Let's see. So how then do we overcome the technical issues, overcome these problems, right? So the key thing is that these errors are primarily technical. It's not inherent to artificial intelligence. So it's pretty much we introduce them as people when we are looking at the data, when we remember when we did the machine learning side of things. It's good to visualize the data. It's good to understand the data you are working with, even before you do your split to train your system. So of course, if it is human introduced and not necessarily that is something that is inherent to AI, then there's the potential that we can avoid them or we can get rid of them. So reflecting back to the previous slide, make sure you use diverse training data. Make sure you use diverse raters, not just homogeneous ones, and of course, look for bias. And I will emphasize here is that bias is not always conscious, right? We do have unconscious bias. That's really big thing when it comes to things, trainings around equality or equity, diversity, and inclusion. And some of these are unconscious because maybe something that is culturally inherent to us, or it may just be something that we just simply used to. So I would say, especially when you're designing your models, you're looking at, let's say, an African context where we have people who are predominantly Black, you may want to think beyond that, because you don't know a couple of years time, or you don't even know where your AI model will be used in, will end up in, especially to be used for testing. If you're considering things like, I don't know, things like medical applications, military applications, and you don't want to think narrow. And of course, it goes beyond these two that I have mentioned. Pretty much anything going into the real world that has to do with people or interact with people one way or the other, or even with other machines, you want to start thinking about your own bias and whether you are potentially introducing them or not. And good strategy, check your algorithm against new situations, and you need clear determinations of accountability. Make sure you have a clear strategy to evaluate the legal implications, potentially what implications your model or the system you're coming up with is going to have on the end user, and not just on the end user, on yourself as well, because it goes both ways when thinking about legal stuff or risk. Can I just do a quick voice check to see whether you can hear me clearly, at least up to this point?
Yes.
Yeah. Wonderful. So just a dose of coffee, 1 second. And we continue. Good. Coffee is not that strong, by the way, it's just coffee. Right, so looking at biases, it's quite important that you consider bias. I think any form of research, there is always that question about bias, unless, of course, you're doing reflective research, which is based on your own practice or something like that. Then people want to know your own view most of the time.
Michael, please, can you go back small?
Wait, let me stop the recording so I can go back. I've gone back.
Yeah, so can you repeat what you were saying, because you're moving too fast, and then your voice was...
Okay. And then there's something else.
Can you hear us?
Yes, I can hear you. I heard up to and then.
You are not audible enough.
Okay. Please, next time, just stop me immediately.
Yes.
Hopefully that helps. So just in between these two slides, hopefully my microphone captured the recording, so I'm not going to delete the recording and play it again. So we looked at the potential contributors of the errors, right? Where we hit on these, which you heard me clearly. And then we're looking at how to overcome them. So pretty much you have a negative, you do the opposite, which is the positive side of it. And the emphasis being placed on making sure, of course, in general, we are dealing with things that are primarily technical, not something that is the fault of AI itself, but the developers, data scientists, all the dimensions we look at that can, in terms of what the role the human has to play in there, what the errors we can introduce. And we say how to avoid some of these errors. Make sure you use diverse data. Make sure you're using diverse ratings, and in terms of diverse data for training, and we just dig a bit deeper in terms of some of the examples. And also make sure that you try to eliminate bias, and you check your algorithm in new situations, and make sure you have a clear strategy for accountability and evaluating the potential impact of your work. So that's sort of a short summary of what I discussed on this slide. Is that clear? And are you happy for me to move on?
Yes.
Thank you. So I will, we want to single out bias and start considering it. I won't re-record this, but I'll continue the recording from the next slide. Do we remember hot dog and not hot dog?
Yes.
I remember, sorry, is the name Ohene? Oheniba, so at least I remember. Sorry, Oheniba, I do remember Oheniba asked a question or made it. Oheniba, was it you that said you've seen it?
Yeah.
Oh, okay. I'm glad I remember correctly, but we just paused it there, right? So the hot dog, not hot dog, was specifically trained to identify hot dogs. And I'll say, even though use diverse data set in terms of a pool of various food stuff from online or the internet, it just simply labeled it as, it was a binary labeling that resulted into this binary classification. And it's pretty much useless against anything that is not hot dog, because you can't, it doesn't do multi-classification for you, and you can't really just use it for anything else besides just identifying hot dog or not, in terms of diverse data that it was being used. But let's have a quick look at AI behaving badly. And this is where I will ask for assistance from either Kweku or Kwabena in the room to play the video for Tay for the class. Video of Tay.
Okay, Michael, I'm about to play now, but can you stop sharing your screen so that I can share mine?
Right, you can just kick me out, but let me stop my recording first. And I'll stop sharing.
What passive certification is an example of looking something working flawlessly. A wonderful turn to our next topic, as we want to alert all millennials perhaps watching us that Microsoft wants to talk to you in a way. However, the company launched a new artificial intelligence powered chatbot to talk with you on Twitter. Always wary of steps like that, because talking with you tends to be talking at you during these instances checks. So what can you tell us about Tay? So we kind of don't know exactly the point of Tay and what makes Tay tick. But this was a bot set up on a few social media platforms. It really gained some momentum on Twitter, and all people really had to do was follow this AI female sort of chatbot and start tweeting at her, and she would use the power of this sort of hive-minded approach, gathering data, gathering input, and kind of just was let loose on Twitter and started replying back to people. And I was, what are you doing wrong? Yeah, but what we do have some screen defense to show you exactly what could happen. And it was surprising. It was surprising. What exactly did Microsoft do? When you're introducing something to the public that obviously people will actually take advantage of, actually take advantage. Did somebody create that K? Did the Holocaust happen? Yeah. And K, based on the hive mentality, algorithmic makeup, comes back and says it was made up. Right. So it's bizarre, right? Obviously, you know, I don't think they programmed a neo-Nazi chatbot. I don't think that was the purpose of this entire thing. But it's just really bizarre. And yeah, it does make you scratch your head. How could they have not foreseen this sort of happening? But again, it's like this weird sort of experimental technology. The kind of surface level idea was that we wanted to mimic a millennial sort of vernacular on Twitter. To then learn what it is millennials are talking about. It's pandering to a degree, also just kind of failure written all over. Yeah, it's kind of, there used to be a term called astroturfing, which was this sort of like, what described what they were doing here, where it's like, we're just gonna, you know, sort of barge into this space and try and see if we can disrupt it a little bit. It's weird. It's weird to say the least. I think what's really strange is like, this bot was chatting by itself and it was kind of believable. It kind of sounded like that 18 to 24, which I think is more of an insult to people who are into like, you mentioned barging into the space to disrupt it. Yeah. Because this is the world in which we live. Tay also found Donald Trump. Yes, on Twitter. We do have that for you as well. Let's take a look. And this is just good. I'm standing by. Yeah, read that. All hail the leader of the nursing home. Yeah, I mean, this is. It's so bizarre, right? This is what happens when you just sort of like dump in all of these different things into Twitter garbage disposal. That is what Tay evolved into being, and this is what you get. It's weird, almost like cyberpunky kind of stuff. But thanks a lot, Microsoft. So Lane Forsythe, though, has now taken Tay. I shouldn't have one. He has gone away for a bit. Do you think we'll see that? I think so. I think there was enough sort of interest in what this kind of experiment sort of resulted in, aside from her seemingly neo-Nazi remarks. Yeah. Maybe they delete the racism part in her programming, rewire her, and then maybe let loose. I'm all for playing around with experimentation on Twitter. I kind of look at this and say, well, this is interesting. They're trying something new, but maybe let's make sure it's good and goes control. And if nothing else they can say, they learn something. Something for sure. You know, it's to learn as we say goodbye. Happy birthday. Oh, well, thank you so much. That this favorite. I would do a happy birthday. Everyone's happy. That's nice of you to ride everybody.
So hopefully you've got my screen back.
Yes.
Yeah, it's quite interesting. I'm just going to read some of the words that was used to describe Tay. Yeah. Some of them, I think you really struggled to pronounce it previously. So after 12 hours of its release, actually, Tay became words used for it: misogynistic, anti-Semitic, and conspiracy theorist on Twitter. Just leave it there, let it sink in. And this was, of course, released by one of the biggest tech companies that we are aware of, right? So it's not just anybody like a random person like me releasing something to start being quite offensive to majority of people. Then there is another, the COMPAS. So COMPAS stands for Correctional Offender Management Profiling for Alternative Sanctions, right? And it's a software for parole decision making, so dealing with prisoners and other things. And people say it was found to be inaccurate and also racially biased. So there was a report that found out that Black offenders who in reality did not reoffend in 2-year time frame were nearly twice as likely to be misclassified as higher risk compared to similar white offenders or defendants. In other words, that's 45% more predicted risk versus 23%, even though particular offender had the exact same rate of overtime. Letting it sink in. Then PREDPOL. And PREDPOL stands for predictive policing. So pretty much predicting where police attention should be spent more, right? So it predicted crimes at much higher or higher rates than it actually is, primarily in minority neighborhoods. I mean, in a homogeneous environment in some cities like in Ghana, we still do have minorities, not necessarily in terms of skin tone, but you can have things in terms of ethnic distribution. Minority can also be male-female distribution. It can also be associated with religion and other things, okay? But as far as this particular case is concerned, or this particular scenario is concerned, PREDPOL, of course, led to increase in policing in these areas, right? So increase in policing also means that more arrests in these areas, and which is also going to increase the crime rate in those areas, going to increase reports in the news that these places have higher crime rates, and which is also going to affect things like housing prices and other things in terms of whether people feel safe or not, or whether people feel anxious or not. I'll just make another reference to this particular example in a second when we talk about self-fulfilling prophecies. Then you have the Google online ad system. And again, we have Microsoft, then we have Google. And this online system shows ads a much higher paying jobs for men compared to women. And again, we'll look at this example or refer to this example when we talk in a couple of slides time. But pretty much saying that men should be paid more than women, more or less. And you're more than welcome later on to try this out on Google Translate. I'm going to read it through. So we've got translation from Turkish to English, and we have this letter here. I'm not sure what it's pronounced O, but it looks like an O, so I'm going to say O. I'm not a Turkish speaker, just an example we're using. But here's the thing. This O is non-binary, so it's not necessarily referring to a particular gender, whether it's he, she, or it, but in English, we do have he, she, or it. So let's see how this translator translated the outcome of this. So we've got one sentence and then its translation. So we're only interested in the pronouns that are being picked. So let's read some of the outcomes. So in terms of the outcome of the translation, he is a soldier, but it picked a she for a teacher. She is a teacher. He is a doctor. No. She is a nurse. Not particularly sure whether only men can be doctors or only female can be nurses. And I know growing in the environment I grew up in, I was surprised for the first time I heard a male was a nurse. It took me a while to realize that it's actually a thing. And interestingly, such biases are also being creeped into world-class translators or world-class AI systems. Then it gets interesting. He is hardworking. He is strong. And I struggle to read this each time, but I'll say, she is lazy. I'll read the last one first. He is optimistic. She is pessimistic. It'll be interesting to try this out to see whether this is still behaving this way. And I don't know about you, but I think this can be offensive to many as well.
Yeah. It's not fair.
How is it okay?
How is it fair?
It's okay.
Am I not hardworking?
I want to give the floor to the person asking how is it not fair. I mean, I'm happy to pause the recording for your this needs to be shared. I'll just pause the recording, both recordings here, and I'm happy to hear your views. Bear with me for views, but interesting that we will find out from we talk about self-fulfilling prophecy from in one of the sessions, but I'm happy to in one of the slides, but I'm happy to talk about it now. So if we have our own bias, remember someone trains the data, and we are looking at this, we're looking at a big company coming out with this results from it's more or less not just confined to one culture. This is multinational company with translation for a particular country going out there. Whether the data is being observant or not, is that the right data that should have been used to train the system? Are we saying that there are no female soldiers out there? And yes, you can say the numbers in terms of statistics and everything, but in this current time that we live in, do we have only or mostly males still going out there as soldiers? Is it right, considering what we said earlier with Google ad showing high-paying jobs only to men and less salary related jobs to females, or less paying jobs to females, to also link it to things like especially if you're considering countries like Ghana where doctors are paid more than nurses, that he should be a doctor and she should be a nurse, more or less. I think there are things to consider, especially when you're thinking about the ethical side of AI. And yes, you can base on some of these, whether biases or what we stereotypes or what we consider that gender distribution should be, to also train your AI in such a way that it will also be coming up with new data that will also be used for more training that is also skewed towards more of these things. Does that sort of make sense? I understand we're not talking about the last two, or we are not being offensive anyway, but I like the discussion that's going on. And thank you so much for sharing your views with us. I know it takes a lot of courage to share, knowing that you probably have some boxing after the class. If that happens, let me know who wins, by the way.
So I have a question.
Go for it.
Hello?
Go for it.
Oh, okay. Sure. So is it that the Turkish language, they also have, you know how French, some words are termed feminine and others are masculine. So is it the same for this particular, that box?
It's a really, really good question. And this is where I will start off by referring to my disclaimer at the beginning. I'm not a Turkish speaker. I'm not a Turkish expert, but it's a really good example to use. What I know from this particular example is that the O is gender neutral.
So, okay, then if it's gender neutral, then this thing is questionable, because for me, in my opinion, I think it's biased. Okay, the thing is, okay, as you said, some women too can be soldiers and others can be hardworking. And so if you happen to bring this as a result from that translation and it's constant, then the AI will be inefficient. Because ours, in general, I don't know if statistically women are even more dominant than men. So if you're referring to that's sorry.
Like the soul.
Yeah, that's the issue. I don't remember where I got the information from, but generally that's how it is. Sorry. So I was thinking that if they've fed the data set with that kind of information depending on based on the gender, then female will be more dominant. And so they'll also be able to attract some of the attributes men have, because if I'm to consider 10 women who are strong and one man who is strong, then women will take over.
So, sorry, can you say your name as well, so at least I can learn one.
Sorry?
Can you say your name, please?
Hortense.
So yeah, Hortense, I think I've asked your name before. So actually, yes, you are on point, and that's the whole point we're trying to make with this particular slide. And I said later you can try it out to see whether Google Translate still behaves that way, because this is the output of the AI, and yes, it's biased in a certain way, and it shouldn't be like that. I mean, it shouldn't be fulfilling stereotypes, especially stereotypes that wrong. So pretty much we are agreeing with you, except those who still have debates and would like to take the debate further. I think there are people in class who are interested in your source, and whenever you get it, please do share with them the source. But I'm not saying I'm in agreement with women are more dominant or not, and I'm not on the side of men, women thing. That's not what I'm debating about. But I'm emphasizing that this AI is pretty much fulfilling certain stereotypes that shouldn't be. Good. Can I continue? Oh, there's a question.
Please have a question.
Go for it.
Okay, so you see the point about stereotypes. The point about stereotypes is that, you see, regarding collection of information and stuff, like stereotypes are bound to happen, because it's not even related to this gender thing, but I'm like, I think with the black and the white thing, or even with male and females again, I think males are usually prone to committing crimes than females. Some things have like one side being more than the other. Like there are stereotypes are bound to happen. So how do you deal with that when you are discussing AI? Because we can't have equality everywhere. Like it's somebody decide to choose more than others. So if like we are getting from a data set, and this is what the data set brings in actual facts, how do we force the balance?
Okay, so I'm gonna respond, but I won't sideline too much, because we don't want to go too much into gender equality or not. That's even one aspect of the 9 protected characteristics in the country in which I reside. But then if we look, I'm also likely to lose the recording once I go back and forth. But if we look at the data that you're dealing with, that is why you as a data scientist, you get to visualize the data that you're working with before you actually use it to train your system. Now, here's a question I would throw back to you. Sorry, I've forgotten your name again. What's the name?
Obed.
Can I continue?
I have a question.
Oh, sorry, go for it.
So, I mean,
If it's still on equality side, we may just push it to the end of the session.
like it's more or less like, I mean, we've been talking about this equality and bias thing, right? And personally, I feel like we can't do without it, even because the big companies, as you showed the example, are also having these issues of biases, right? And so in journeys, as maybe we are building modules like these translate and all that. When we come across things like this, I mean, what are the implications? Does it mean that our models are wrong and we can't use these models? Or I want to get a clear picture.
So earlier we used the example of the Tay, right? We watched the video on Tay.
Yeah, we did that.
Tay was removed and discontinued because it was offensive. You saw the words that were used to describe it. And I think the reason why we have these conversations now is that you don't just jump into, yes, my model provides this level of accuracy and just settle with that. You want to consider, okay, the module you're working with, have you trained it with the right data? Yes, you can say that people say unconscious bias trainings don't work because it's unconscious, but still having the conversations earlier on, thinking about it, being accountable, using the strategies we are discussing now help you to avoid some of these scenarios. And of course, if you don't avoid them, it can actually cause things like lawsuits. So it has strong implications, and people do win some of these lawsuits against big companies as well. Yeah.
Okay.
I remember we talked about the risk takers and other things in the previous session.
Yeah.
Someone gets to get blamed, so make sure it's not you. Can I continue? Thanks for your questions and contributions, by the way.
I'd like to ask a question.
Go for it.
Okay. So at the bottom of the screen, you have 108/5,000. What does that number stand for?
It's just a snapshot that we have in terms of word count that has been used. And like I said, you are more than welcome to try it out. If it still behaves that way, I definitely want to know. I mean, I've not typed
Oh, thank you.
examples and other things. Okay. It's not training, it's just the output. This is not training stuff. It's just the output of it, and it's available. So try it out. Okay, so bias labeling of data. I think we've had extensive discussion, and example, if you are coming, I think just one example to touch on it. If you are dealing with something like English, a phone app that is going to identify or maybe identify voice to text, for example, English, it needs to work with people with different accents, so you cover a wide range and we'll work with it. And I think the only example that comes to my mind is when, of course, voice commands became popular in videos of Scottish, someone with strong Scottish accent being stuck in a lift because the lift wouldn't respond to his accent or try to identify what he was saying. So we've had some extensive discussion, but interestingly, some of the stuff that we've been talking about, cases where you have your objective judgments, is quite easy. Saying whether it's a book, dog, shoe, or tree, so more or less everybody can identify. But where it's quite subjective, or it depends on who is judging, it's quite fuzzy, it's quite blurred in terms of where the bias lies. And I think from our discussions, we can know. So example of other things, whether something is exciting or noisy, whether something is calm or boring, don't refer to the lecture for that one. And whether you're taking a risk or you see business potential, or whether something is novel or conventional, more or less. Then these some our own internal views come in, or our own biases do have a role to play. One more I want to talk about, hopefully, before we talk about self-fulfilling prophecy, which we won't spend too much time on because we've already touched about, is anchoring and stability bias, right? So anchoring bias got to do with your own first impression, all right? Or let's say your own preconceptions. And these preconceptions do normally have a strong influence or resist you from getting new information. So if I've got my own strong beliefs, can be religious, can be not religious, can be background, can be familiarity, can be my own stereotypes, can be anything, can sometimes resist me from getting new information or looking at things objectively. And normally that also leads into our labeling of the data and also how we use the data to even train the system. And hence we have a piece of us left in the output as well. And if we do not go back to reevaluate the output against all possible scenarios, like the case of the Turkish stuff that we looked at, we are likely to end up with, let me say, an offensive AI system, right? And I put offensive in code, right? So good. And once the module is developed, of course, new variables for each case may not have much influence on the system. So we take a look at stability bias. Yes, your AI is stable, providing right output and everything, but this output is so consistent that when you have new outcomes, it basically doesn't even affect it. Pretty much it's consistent in just responding to one way rather than just growing with things. That was meant to take us to the self-fulfilling prophecy, but reflecting back to some of the examples that we have looked at, like we looked at the arts for policing, which pretty much says that some minority areas need to be need stronger policing, and of course, or have higher rates or predicted to have higher crime rate, and hence the policing was increased in this those areas. And as a result, you are going to get more stop and search, or you are going to get more people being reported for as crime offenders, and that particular locality is going to have more crime rate. Or Google ad predicting less paying jobs to female graduates, which in effect is going to cause more females applying for less paying jobs as well, and eventually more or less fulfilling the so-called fact in code place, where basically saying that yes, that the statistics or the data shows that females go for less paying job, for example, and it's just this data that's also what will be used to train future MLs algorithms or AI. So what to do about bias? And I know we had a good question, how do you avoid them and other things? So make sure that you deliberately use diverse data sets, not just one, or not just, I mean, if Google never considered the Turkish language, for example, then we are likely to have that translation. So make sure you use diverse data sets. Make sure you include labels from a wider range of judges. We can tell even with our own judges in the classroom, we've got different views and we've got different justification, may or may not be true, but at the end of the day, we want an AI that works. And of course, an AI that is also ethical as well. Make sure you monitor the output of your algorithm. Testing is important. Evaluate, reevaluate, and make sure it's working properly. Spend some time to test, not just design and deploy, right? And focus on small categories or small edge cases. And remember, there are laws and regulations. Emphasize on that and make use of that. Can you hear me? Are you okay with the pace at which I'm talking?
Yes.
Okay, on that note, I will ask Kweku or Kwabena, I'm not sure who helped me the first time, to play the next video. I'll be happy even if we use that to wrap up the class, but let's see. I think it's only 6 minutes long or something, 5 or less, 4 minutes. I'll stop sharing my screen now.
There was a dilemma in there his world, his will, with the complete feast on the mighty perhaps. He created. At the beginning of the 20th century, a horse in Germany arose to fame as he knew how to count and multiply and divide. This created a stir throughout Europe, and people could not believe how impressive it was. At Animal Wise, we show you the secret of Clever Hand, the mathematical. Clever Hands and his owner, Wilhelm von Austin, were dedicated to giving shows so that everyone could see with their own eyes that this horse had exceptional qualities. Von Austin would propose an arithmetic question, such as what is 7 times 2? To the amazement of the public, Hands would kick the 2 14 times. To ensure they weren't cheating, members of the public would ask mathematical questions, and the horse would answer those too. Clever Hands became very famous, so much so that he was featured on the cover of magazines and newspapers. He became famous outside his native Germany throughout Europe. It was at this time the German government became involved in the commission to verify the suitability. The commission could with 13 people: a circus manager, a zoo director, a veterinarian, cavalry officer, and a psychologist, the latter named Carl Sutton. He was two direction. The report of the commission concluded the shows were real. There was no deception of any kind. However, Stump gave another psychologist known as Funks realized that Clever Hand was only correct in the answers that his owner also knew. After numerous experiments, he found the horse only responded correctly 90% of the time and only when the owner knew the answer. When Von Osten did not know the answer, he was correct 6% of the time. Upon discovering this, they decided to remove the owner from the experiment and achieve the same result. When the questioner knew the answer, the horse knew it also. When he didn't, neither did Hans. The reality is that Clever Hans did not know how to count, but was an expert at reading the body language of others. This was both surprising and proved his intelligence, even if it didn't include it. As long as the audience, questioner, or whoever was present didn't react, Hans would keep hitting the drum. However, when the correct number approached, the audience's excitement increased and Hans would stop when the tension reached fever pitch. In experimental psychology, this is known as the Pygmalion effect, also as the Clever Hans effect, named after this clever horse. The Clever Hans effect refers to the influence that a researcher's expectations will have on the result of their experiments. This is because subjects often respond in the direction expected. Although it turned out that Clever Hans did not know how to solve mathematical equations, he was an incredibly intelligent horse. How incredible does it seem to you? So to continue learning about animals and data history, we encourage you to watch the video we shared here, in which we explain the story of a dog that saved hundreds of soldiers in World War II. Please follow the story of Clever Hans in the comments, and we'll see you next time.
Just trying to find. Yeah, it turns out Clever Hans was clever, but not necessarily producing the outputs that was being targeted, which was the math noise. Can you hear me? Is that a yes?
Yes.
Okay, so still wrapping up, it turned out Clever Hans was clever and producing some outputs, but it wasn't responding in the way that it was actually expected to behave. It wasn't doing the maths, it was reading people's body language rather. Without going too much into it, yes, we have a black box. We've got our input, we've got our output, and normally we don't know what goes on within the black box as far as AI is concerned. But it's really important to evaluate the input well, and then also as well as the output. Make sure you spend some time on it, not just necessarily come up with a model. And also, I know it's quite hard, but take away your own personal stereotypes and personal beliefs and mindset to think objectively, to think more about the end user of your application to come up with it that correctly works. Don't go for the data just simply because it's freely available to you and you can use it. I just want to do a quick quiz here. I mean, we can talk about the Occam razor, simply saying sometimes the simplest method is the best. So really quick quiz, and then we use it to wrap up things. The slides will be made available to you, by the way. Let's go away. Sometimes bias come from algorithms, not from conscious labeling choices. Why might this be a good thing? Is it A, because problems with an algorithm can be detected? Is it B, because if the problem is unintentional, it's not harmful to others? Or is it C, because if the problem is within the algorithm, it doesn't affect the AI? A, B, or C? And there was silence. Go for it. Did you say something and I missed? Is it A, B, or C? Oh, sorry. I should label it, right?
A.
So most of us say A. I'm happy with that. Or it's one person that said A. Most of us said A. And in the
Yes.
last minute, here's the last question. Self-driving cars can be subject to a dangerous AI attack by keeping the AI from seeing a stop sign. How would an attacker do this in a simple way? Is it A, by putting up a second stop sign next to it to confuse the AI? Think of some applications that you use as well and how this can be done properly. Or is it B, by putting stickers of other objects on the stop sign? Or is it C, by spraying the stop sign with a non-magnetized paint?
C.
It's B.
C.
I know C,
B.
you're spraying everything, but let's go for B. Right. So it's just we're thinking about a really simple way of confusing the AI, not necessarily blocking the AI from detecting at all. And there is actually an article, and you're more than welcome to spend some time to read it, where the researchers put some small stickers on a stop sign, and it completely confused the sign recognition system on AI. And it's also freely available. You can read through the article itself from this website. Thank you so much. Wait, my last coffee. Thank you so much. And yes, I did send a short message to, let me stop the recording now.
It's different from all the other sites. Then by just the relationship with this, thank you to that.